Friends, welcome to s.mathguru classes. Now our main discussion is total differentiation. Today we consider the new topics total differentiation. So it has a proof. Some proofs are given directly. I left the proof and directly I use the formula only. The total differential coefficient. Suppose z is a function. Let z equal to f of xy. This is the function. Then dz equal to we can write del f del x dx plus del f del y dy. This is called total differentiation formula. dz equal to del f dx dx del f del y dy. dz is called the total differential of z. And corollary 1, differentiation of composite function. If z equal to f of xy, where x means phi t and y means psi t, here z is composite function of t. Dividing 1 by dt, this is equation number 1. If we dividing by dt, then we have dz dt, dx dt and dy dt. We get another formula. dz dt is called the total differential coefficient of z. This is another formula. This is first formula, this one another formula. Again corollary 2, if z equal to f of xy and x equal to phi of uv and y equal to psi of uv, then also we write this formula by using these two. Del z del u equal to del f del x del u, del f del y del u, and del z del v equal to del f del x del v del f del y del v. So this is how we can express in this way. If another variable we get z, then also we can write extend with this del f del z del u, just like this. These are when we solve some problem by using chain rule, then we using this formula also in partial differentiation. If using chain rule, then we can use this formula also. These are the main formula for solving some problems of total differentiation. Now let us consider some formula. You have to by heart this formula, this and this two. These are most important for solving some problems. Now we consider one problem. U equal to x cube plus y cube, where x equal to a cos t, y equal to b sin t. Find du dt and verify the result. So this is our problem. Now solution, we have u equal to x cube plus y cube and x equal to given a cos t, y equal to b sin t. These are values given. Now our requirement du dt. Now du dt can be written as del x del u del x or dx dt plus del u del y dy dt. By using the previous first formula, we write this. So this is the second formula, formula number 2. Using this, we have to find this. Now del x u means x cube plus y cube, and ddt of x means a cos t, ddt cos t plus del y u x cube plus y cube, ddt of y means b sin t. We get this. Just putting the ready-made values, we get this. But this is partial differentiation. We differentiate with respect to x, then x is variable, y is constant. So this is 3x square plus 0. Del x of y cube 0. And this one a d dt of cos t means minus sin t. And this is partial differentiation with respect to y. X is constant 0 and y cube means 3y square, and b constant outside, d dt of sin t is cos t we get. So ultimately we get minus 3 x square a sin t plus 3y square b cos t. We get this after calculation. We putting the values of x and y. X means a cos t, y means b sin t. So if we putting, this is thrice a x. X means a cos t and this is sin t. 3b y. Y means b sin t whole square cos t. This one a square cos square, a square and a, this is a cube, cos square t sin t. 3, this is b square sin square, b square and b cube sin square t cos t, and this is our answer we get. By calculation we get du dt, this is the answer. Very nice solution. But problem given and verify the result. If we verify directly whether we get this result du dt, we get same result or not. Verification you consider. In verification, u equal to x cube plus y cube, this one given. This implies u equal to x. X means a cos t whole cube, and y means b sin t whole cube. This implies u equal to a cube cos cube t, and this is b cube sin cube t. We get this is u. Now we differentiate this. If we differentiate this, du dt, a cube is constant outside, d dt of cos cube t, b cube constant outside, d dt of sin cube t. We get this. Now if we directly write the result, then a cube 3 cos square t and d dt of cos t means minus sin t, and b cube, if we differentiate directly, 3 sin square t and d dt of sin t is cos t. So ultimately we get 3a cube cos square t into sin t, 3b cube sin square t into cos t. So what we get, this result and this result both are same. 3a cube cos square t sin t, 3b cube sin square t cos t, and both are same result. So what we get, therefore both are same, hence verified. This is the verification. We get this one. Very nice solution, very easy. Another problem. This is very interesting and very simple. If z equal to f of xy and x equal to e to the power u plus e to the power minus v, y equal to e to the power minus u minus e to the power v, prove that del z del u minus del z del v equal to x del z del x minus y del z del y. So this is our problem. Now we want to solve this problem. So x equal to given e to the power u plus e to the power minus v, and y equal to given e to the power minus u minus e to the power v. First we find del z del u, del z del x del x del u plus del z del y del u by using formula number 3. This is called chain rule formula, and putting the value del z del x remains same, del u x means e to the power u plus e to the power minus v, del z del y, this del u y, e to the power minus u minus e to the power v, we get this. So this is del z del x, we differentiate partially with respect to u, then this is variable, this one constant. Del u e to the power u means e to the power u, and this is 0. Del z del y, we differentiate with respect to u means this is minus e to the power minus u, and this one 0. Ultimately we get del z del u e to the power u del z del x minus e to the power minus u del z del y, we get this one. Consider this is number 1 using formula number 3. Again we find del z del v. First we find this, next we find this. Del z del v, we can write del z del x del v plus del z del y del v, this one. By using chain rule formula number 3, we get this. Now again putting the value del z del x remains same, del v x, this value e to the power u plus e to the power minus v plus del z del y, this is del v y means e to the power minus u minus e to the power v, we get this one. And this is del z del x, we differentiate partially with respect to v, v is variable and u is constant. First one 0, and if we differentiate this minus e to the power minus v. And del z del y, this is 0, this is e to the power v. Ultimately we get del z del v minus e to the power minus v del z del x minus e to the power v del z del y. This is number 2 we get. But in our problem del z del u del z del v, this is middle is minus sign, so we subtract this and this. Subtract 2 from 1. Now simply we write now 1 minus 2 implies 1 is del z del u minus 2 is del z del v. Del z del u, we get this result, this one, e to the power u del z del x minus e to the power minus u del z del y, and I subtract this, then this will be plus e to the power minus v del z del x, and this minus will be plus e to the power v del z del y, we get this. Just we subtract this to this minus this, we get this result, and we calculate the right hand side. Taking del z del x common from these two, we get e to the power u plus e to the power minus v del z del x, and from these two taking minus sign common, e to the power minus u, this plus will be minus e to the power minus e to the power v del z del y. We get this one. So this implies del z del u del z del v, this value we get x we get this one, del z del x, and this value we get y del z del y. So this is our answer. Prove that del z del u minus del z del v equal to this. Ultimately we get this our answer. Hence proof. This is our proof. So these are very simple problems. I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.